Hello, welcome everyone. My name is Usama, and you can call me Usama as well. Full name is Usama Wahab Khan, and I'm here. I'm really, first of all, thankful for my whole team who have arranged a fantabulous day of tech out there that will tag day Pakistan, and I will be really fortunate to be a part of it out there. Who am I? What I'm doing here? Let's directly jump into it. But before that, we're going to have lots of Azure goodness today, and especially segment of data engineering. Oh, goodness. So who am I? As I said that I am Usama Wahab Khan. I'm a big time community guy. I love to contribute in a community in so many different ways. I'm a published author of 3 books now. And from last 5 years, I'm working as a chief technology officer for Evolution Technologies. And prior to that, I was senior vice president and acting CTO for Middle East for capital market deals out there in Capilive. It's one of the leading private equity solution provider and ex-MSFT. Love to share my knowledge. As I say that, we love to contribute. So I do lots of trainings with the parks of partners out there. And I've been considered as the top 5 beloved uh, training mentors out there in the world. And I have contributed in a course that called TP200, which was on a previous course for data engineering. And I'm continuing my fellowship for MCT from last 10 years approximately out there. I'm very proud of it. And I'm nothing more proud of my beautiful 2 daughters. Now I'm a father of two, thanks to Gurgit. And yeah, I love my life and I'm enjoying my time with them. After the class, after the session, during the session, you see that how much classes are on my head. So during the session or after the session, at any point you guys like to talk about this or talk about anything that related to that it excite me or have a correlation with the topic out there, more than happy to grab a 2 chats with you guys. And you can catch me over Twitter or LinkedIn. LinkedIn is getting very scattered. I have 13 to 40,000 followers out there. I don't know how to handle that, but Twitter, I'm pretty good on it. I reply most of the time. So let's directly jump into it, our session out there, and we're going to talk about Azure data engineering out there. When we talk about the data engineering, there's so many segments out there. There are so many things that we have to keep eye on it and market trends out there. I've been into trainings out there, and I am also working with it closely within our enterprise community out there. I'm based in Dubai from last 10 years and pretty heavily covering a European, North American, and Middle Eastern market out there for perspective and integration and consultancy perspective out there. A, a segment which I have seen dramatically change in the last 5 years or in the last decade, if I say, it's data engineering segment. This whole role evolved at that time out there. And one of the key reasons that this whole new job description get new meanings, it's because of the cloud versus on-prem evolution out there. So that evolution that happened out there, that transition that happened from on-prem to the cloud, make all thing difference out there. It's making a really, really big difference out there. So first of all, let's talk about what is a cloud versus on-premises and why it makes so much a buzz in a market and why it's so different. We're still doing a compute, we still have VMs out there, we still do storage out there. And then somebody's like some great man says that it's someone else's computer. For sure, it's someone else's computer, but whose? It's ours. So as we know that the cloud available in a 3 different configurations out there, private cloud that is owned by the one organization, used by the one organization, like owning our own data center, just outsourcing and providing services to departments out there. We have also concept of public cloud or commercial cloud. So public cloud, commercial cloud, consumer cloud, all are the same things. And it's mean that one company, cloud solution provider like AWS, Microsoft, GCC, any of them, you're providing US services and you don't have to pay in advance. That's a big one of the key advantage. So they have hosted their services, their products out there, and they offer compute, network, and storage out there. But the most fundamentally, you don't own the things. So that cost of ownership is very low. So initial investment is very low out there. From a financial perspective, it's a great advantage because you can put that amount, that investment, that budgets into your R&D or scaling your product or extending your product out there. Previously, the projects where we work on, especially in the data sites, are very expensive, especially when it comes for the hardware. using storage solutions out there, analytical solutions out there, buying expensive sensors for suppose, advanced high power computer sources. And most of the time when they're idle, they are still costing us. In this environment, you get a different variety of computer sources and very unique. It's super integrated. It's super agile. When I've been to the meetings out there, people ask me this thing, uh, what's your selling point? What's your USP out there? Is it cheap? I say, no, it's not less expensive or cheap out there. It is more agile and more innovative. People now moving to a cloud, not because of just money out there. I believe me, I do sales in my region out there. I know my region. I know how things are moving out here. We thought that it will be a USP that you can save bucks of money. For sure, it is. But one of the key things that the innovation, the new systems, that how integratable they are, how faster they are, how easy they can make those pipeline possibles for us out there. The licensing model and the maintainability reduce a half our work ahead from us, give a lots of maintainability, compliance management, and GRC management on the vendor side, so that we can focus on something that matter most. And we can scale up at any point. That's one of the fantabulous advantage of a whole cloud scenario out there. You can scale up at any point. You have that elasticity out there that you can configure different kind of configuration, and you can get for your POC, for suppose you want to test something, you want to do a smart R&D out there. You can't get an enterprise hardware in a previous world out there. You can't run an ETL jobs on a 50 terabytes of data out there. You can't. But now you can in just one click because you have access to all those resources, not impacting anything in your organization out there. Same thing with availability as well. One of the key challenges that making any solution out there is to make it available, compliant with your SLAs out there, to make sure that its availability is not going to be compromised at any point out there. So all those fundamentals, all those goods are coming on an single shot out there, which make a very powerful impact on industry out there. If you just talk about the Middle East industry out there, for IT industry sector out there, its cloud is booming and ravishing up at the moment out there. And the reason is this, almost adoption rate is 61% to 71%. You can imagine how fast organizations are trying to adopt the modern cloud technologies to implement their solutions out there. I think what change in the cloud is super advancedly is storage, the way we use storage out there. So now, since you guys know that this whole concept has been changed, this whole new conundrum gave a birth to lots of new roles out there, or give a new definition to the roles out there. One of them is data engineering roles out there. And data engineering role is basically record lots of things out there. It is first of all, when you're moving from a cloud on-prem to cloud, you are moving from a concept of implementation to provisioning out there. You might have heard that people have said in the past that we are implementing SQL Server. Literally, it wasn't a job out there. I was on a back in my days SharePoint guy. I have been a Microsoft MVP for SharePoint for 3 years. I have 7 MVP awards in my career. And you believe me, you get surprised. Just to establish a one box of SQL Server out there for the production environment took weeks sometimes out there. I worked with several of big names in industry out there, and in past, especially in a SQL segment, and it like PDCL, I can give you a name in Pakistan. We worked with Nadra, we worked with also few embassies out there. We have worked in a collaboration with the Ministry of Labor in Dubai. We have worked with the Saudi Hajj out there. We have worked with the RTA. So we have worked with several of organizations out there, Alpha 10, Emirates out there, and establishing their just SQL boxes took lots of time out there. And it's, believe me, it's a hell of a job. It requires real skills out there. But now that implementation aspect also, almost 80% of stuff has been wiped off. Now it's provisioning. Writing one ARM script, one PowerShell script that's come within the best practices, verified, testified, descriptive, and implemented the old DevOps goodness in it. Well, you're in out there. Which what new skills? Back in the days, infrastructure as code, modern DevOps techniques, SACS, oops, those things doesn't exist out there. It's a new era of a new terminology and a new responsibilities and new platforms out there and how they work together. We don't have a concept in past like in a continuous integration. We do not have a concept of a monitoring, deep monitoring, infrastructure monitoring, insights monitoring out there. But now in 2022, you have those stuff. You have to integrate. The challenges are more advanced. The cybersecurity threats are more advanced out there. So you have to provide that things out there. And changing the loading approach. One of the things that changed in a data engineering job out there in the past few years out there, it is basically a shift from how you load data, not in a data solution, how it works out there. So I have a pretty nice slide. I'll just going to talk about that one. So out there, a second. I got this new keyboard. I'm trying to get used to it, but things I will take some. So the loading approach, that how you load data, because data is stored in various positions out there, different systems out there, and it could be in your SQL server, it could be in a HDFS or somewhere else out there. And the previously we used to extract the data, transform data, and then load that data out there, which means entirely change in a cloud world out there, because we're not doing those whole processing and expensive compute out there. We are just loading a data, because now data is stored in a much more massive scale out there. It is another concept that my folks or my attendees you need to be understand here. It's a data ambulance concept here. Means that it's a whole data catastrophe out there. Means that a whole bunch of data out there. If you guys might get surprised, that all the data that we have in this world today, it's 90% of them has been created in the last 2 years. So imagine the velocity that we are creating of the data. So it's a very high velocity of collecting data out there, because we have those components, and data is coming in so much variety, and data is coming in a far more variety than ever before. It's coming from IoT applications, it's coming from systems and applications and raw applications. It's beyond imagination, believe me. And the volume, so that they call a triple V out there. So the volume, and that make a whole impact at how we load data. Since the data is so scattered, it's difficult to transform them fast out there and load. It can be very expensive. That's why you have systems like Hadoop and other things. And it changed the approach for data engineers out there. So if you're already in a data engineering, it's going to be changed and shift for you as well in a cloud. But many people have this concept that what is data engineering and what is the role of data engineering, because we don't heard much about that. We have talked about the DBA, we have talked about the admins, we have talked about the developers, we know about the data scientists. What are these new roles out there? It's evolution of the previous segment, and it is data engineering role. It's basically one of the key coordinator on the product or on the project of data out there. You have a data scientist, the guy who built the guy and the girl. I should be unisex upon that one. Correct me if I'm wrong. So the person who basically perform data modeling task, who person who just create a machine learning models, use a hyperparameterization, use other kind of segments out there to just create a predictable models for analytics and decision making. So technically, person who work with the machine learning and built machine learning models with the data, that person called a data scientist. Then you have an AI engineers. Whom are the AI engineers? AI engineers are the one who use the pre-built products, who use the product that's been built by the data scientist and built and embed them in their application. But the actual heavy lifting around the predictive analysis and descriptive and different kind of regression model selections and hyperparameterization will be done by the data scientist out there with the given data. Who will give them this data? Who will give them an access over this data? Who will facilitate them? Who will arrange and deploy and manage all those components out there? Who will perform extract, transform, load, or load, transform, and Excel out there? Who will make sure that the data is coming in the right pipeline and continuous basis? Who will make sure that those models being consumed absolutely right, descriptive and prescriptive model both out there? Who will make sure that it will be preserved fine, the whole environment, security components, everything goes in a single bucket out there, and it will be running fine out there. That guy is data engineering, because it's a data engineer. So a person who manage or call himself data engineer have to work within the provisioning services, have to work within a language like Python or R or Scala to performing the ETL and advanced translation out there. A person who call himself or finding itself out there into the data engineering segment have to work within lots of day-to-day implementation and security aspect as well. They have to closely work with the security teams. They have to closely work with the data analytics teams out there and data science team as well, because the product that developed by the data scientist either consumed by the AI engineer or it will be catered by the data analyst. Most of the time, it go for the data analyst team out there. Reason is this: Those models are designed for performing some sort of analytics, and they are the one who build the serving layers as well. And you also have a data management teams, data steward, data architect, DBAs, and furthermore. Since we don't work on a single data sets out there, so role of DBA has been evolved and mostly transformed into the data engineering side or data management roles out there. So I hope so this whole picture gives you a pretty nice idea and you can imagine and understand that how those rules being worked out there. Again, they are very debatable. They need a very thorough discussion upon it. We have a time constraint, so I try to be a bit lighter out there. If anybody want to grab some more information or want to talk more about it, feel free to join me on Twitter. So the data engineering practices that we have basically so far discovered out there, so we have to focus on the provisioning out there. So we do provisioning of resources, means we build environments out there. You're supposed to configure SQL Server in a cloud. You're supposed to deploy Synapse out there. You're supposed to deploy Databricks out there. You're supposed to deploy, manage, configure, orchestrate with a data factory out there. So those components in a cloud and storage configuration, we need in a hands-on skills on. Then you develop the process because data is coming in a continuous process out there. Data is coming in a continuous motion out there and at different velocities. Sometimes data is available in a very larger amounts out there, like an HDFS, or it available in a larger chunks out there that we call a batch processing. So you have to configure a batch processing out there. So periodic basis, it can just transform and make the data analytical available into stores out there. And some data is coming on a very high velocity and low latency. What is this? That's a real-time data. Data is coming from IoT device, data coming from stock exchange, data is coming from an application or sensor that need to be processed in real time out there. So these two practices we perform out there, and we have to go on and control and deploy those processes out there that they will perform every single task that should be processed in a sequence out there or subsequently. Monitor all processing out there. So monitoring tools and systems are very important. In Azure, you have Azure monitors, you have a series of tools that you should have to take seriously upon that one. As a data engineer, you should have a grip over KQL, and you also have a good grip on Azure configuration of a Microsoft Defender for Cloud and Azure monitors, that how you can use those quantifiable information, those matrices, those logs, analytics out there in order to troubleshoot, performance tuning, and furthermore related tasks out there. Then you have to build within a DR and availability out there. So disaster recovery and DR strategy is important. You have to comply with the governance compliance standards that your organization or standard industry has to follow out there. So for whatever the RPO, RTO, you need to be comply out there. Based on that, you have to define your infrastructure according to out there. That what tool you select out there, what level of redundancy you can go out there, what options suited best you need out there. Should we go for auto scaling? If you're going for auto scaling, you should know the pros and cons out there. That what you cannot do in auto scaling out there. Just for example, I was within the Ministry of Artificial Intelligence in Dubai a few days back out there, and they are planning to use Cosmos DB at that time. And Cosmos DB is Microsoft product out there for non-SQL. And if you go for the serverless edition of them, you cannot do our Azure application upon that. And that feature you was not aware of out there. And they were planning to use complete use case upon that feature. And once I just drop on them, it was a really a big bummer. It was just really a deal breaker out there. So no, that's why we're going on the cloud. We need that. And we change them to the provisioning model out there. So as a data engineer, you should know all those things out there, from disaster recovery, from availability, SLAs, and the optimal positioning out there. If you're someone who's just finding their way, or you're already one who is practicing data engineering, exploring the Azure side, I highly recommend to explore a well-architected framework. Explore the well-architected framework. My fourth book will be coming, I think so, by end of November or somewhere. I'll just post on my Twitter out there. That's I have wrote about it, enterprise practices for well-architected solution for multi-cloud. So I have talked about it, Amazon and Microsoft both in the standard practices. So you might get a pretty nice idea about that one as well. I'll post a couple of chapters around it on the Microsoft sites as well on talks in upcoming days. So I'll put the link if you guys want to grab it, feel free. And the best resource, go on a Microsoft site and just find in the architecture center, there's a segment out there for the WAF. So we're talking about Yeah.
Great. I just wanted to I was kind of curious since I have a similar background. Um, yeah, I'm just sort of curious. Since you have been in Middle East for quite some time, I wanted to understand from the from the data engineering perspective how 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 the trends of or the demands from the clients have changed when it comes to within the data engineering product suite when it comes to COVID to post-COVID era, right? How the different tool set and the demand for tool set and all these sort of um, you know all these services stack within the Azure cloud has changed. What has been some of these trends or some of these things that you've noticed across across the period, like the pre-COVID period, post-COVID, or or maybe during COVID? What has been your observation?
I love to answer that one out there, but this is a very fantabulous questions. So I will save it for the last, just for the like a desert out there, and I just complete that piece out there. That will basically help me to answer your question as well, and I'm going to highlight that one out on that.
Sure, sure.
Sure. So we're going to move back to this quickly. So we know that the data is available in a different sets out there. So you have structured data in databases out there, and you have a semi-structured data available in a segments like in a non-SQL, keyword stores, document store, graph databases, column databases out there. And might be you have also other sort of databases that you want to use upon that one for exploring something in between that cannot fit into the category of a structured databases like SQL structure, the things that you define on design times. So you cannot define a schema on design times so dynamic and so hierarchical and so vast, but still it is a structure. Like graph databases, they are super beautiful out there. Genome studies can be performed upon that. Document database, I love them. Expertise on that side. And then we have our beloved unstructured data. 80% of data is unstructured. So it might be available in Hadoop, HDFS, data lake out there, and many other forms out there. So we have a different type of data. Unstructured data, any data is unstructured data, like PDF files, for documents, for video files, and anything. We don't have a capability to analyze them. That's why they were not using it in past, but now we do. We can analyze from videos now. So imagine where are we going out there. Let's take a look for the key components out there. Here you will find lots of equations out there. So what we are doing in a data engineering, it's important to know, and I'll talk about the post-COVID and pre-COVID and market situation in Middle East as well, and also in Northern and Central Europe as well. So if we talk about out there, so we do a 5 major tasks in normally out there. Ingesting a data, orchestrating a data. That's fundamentally changed in the past 5 years a lot, because data used to be on premises out there and the computer sources are used on a TOC basis rather than pay on demand. So now they have those resources, but the more you use, more you pay. But previously you have the cap that you can use and apply upon that. Now the similar models coming to the cloud as well, but that's how it was, especially for the storage perspective. So the orchestration is changing out there. So you're moving the data from on-prem to cloud out there, different sources to cloud, and from cloud to cloud out there, and you have lots of orchestration engine. In past, you have used of lots of popular tools like SSIS, Snowflakes, uh, Informatica. So there are plenty of things you people have used out there, Python codes and many things out there, custom codes to orchestrate data, moving data from its actual location to the staging servers out there. Then the storage. Storage is entirely changed out there, especially the product that Microsoft have that called Data Lake out there. It's fundamentally a Hadoop HDFS Hadoop data file system out there, distributed file system, and it's distribute data in smaller chunks out there. It is important thing to know. Rather than storing a data in a single box out there, it's going to just store that in small nodes out there across the multiple compute nodes out there. That's why it gives us an opportunity to store infinity amount of data, any amount of data, unlimited. And we can collect the data back with a reference out there at kilometer reducer function out there. We can collect the data back and process it further when we need to analyze. But since the data is scattered so vast platform and horizon is very big out there, it is a very tedious and expensive job to collect the data for analysis out there. Storing and preserving is a lesser cost from password, but now analyzing the data is expensive because every single read have to come in from various systems and apply multiple analytics in multiple data points, very expensive. So you evolve a segment of an in-process memory computation out there, like Spark, Flu, those kind of components out there. So you can train your models out there. So you basically train your models, you basically prepare your models out there. So that's what it changed. The ETL become ELT. That's a huge change in a cloud and post-COVID, especially out there. We are doing previously the ETL out there. We are extracting the data from databases out there, from systems out there, and put them in staging. Then after that, we perform a transformation on it, and then we load into the data warehouses and the serving layers. Pretty dense and pretty simple. Everybody doing boring job. Nobody, Apple people give a shit about it. And now it's very interesting for me, I don't speak. Now data coming so much different velocities out there, and you're extracting data and then loading into the Spark or the real-time systems out there. You're performing lots of things together. Same time you're performing your transformation, enrichment out there, and you're using the same thing for the machine learning out there. I work on data bricks out there, so I do same time data modeling upon my systems out there, and size out there, and work with my data engineering teams at the same time. So they can use the same tool, similar languages, so we can have like a collaboration on it. And in the end, we have a serving layer. So where you serve the data. So where the data need to be consumed out there, and that data shift into the data warehouses like Synapse, cloud buckets out there, and many solutions out there. Anybody can select any based on their requirement out there. But there are a few important things that you must need to understand when you're going for Microsoft out there. One is a Lambda architecture. I don't have much time here, so I will just cut it short out there, not going detail out there. So the Lambda architecture, which basically talk about combining two different streams of the data. One is a batch processing, and one is called a stream processing or the real-time processing together, and provide you into the analytical store, so you can take advantage of enrichment and the details from historical information out there and real-time information for the crispiness. The evolution of that module is called a lakehouse model out there. It's an evolution of a Lambda architecture out there, where you refine a data multiple times and less compute resources and make it more usable upon that out there. And these architectures basically drive the complete scenario, because the shift that happened from Lambda to like Lakehouse, it's pretty dramatic out there. It's very recent out there. And in Middle East also, it's very adoptive out there. So if you see that, then in past that we don't use much tools like Delta Lake architecture here, using a data factory in so much different fashion, and the Spark playing a major role. And in last 6 months, we have seen that Microsoft heavily pushed us that use Synapse analytics out there. And they asked me to conduct almost 30 plus workshops across the world, and I did. But the Databricks is my still favorite. I still love Databricks. I have some small love for Databricks all the time, and it's tool that I'm very comfortable. So you get a chance to work a Spark and a Flow out there. You can also have lots of advantages of node-based style, but Microsoft copied very well, I can say. So now you have Synapse Analytics out there. That's the sample project. So data. Yes.
Thank you. It's yeah. I just wanted to jump in then and tell you, like, it's been really good to understand, the entire architectural differences here. And yeah, I mean, the thing is, I'm quite interested in the fact that, like, there's been a recent, not recently, I think Microsoft has already set up their data centers in UAE, I think,
Yes.
or Middle East, right? Like within collaboration with Etisalat, I think. So after that, what do you think? Like with that happening, has there been any like increase in adoption to cloud platforms?
Definitely, I answered that one. It's not only Dubai.
Yeah.
Okay, it's not only Dubai.
Okay.
Saudi Arabia have their own data center working within a CSTs out there, Saudi Telecom Authority, so Saudi Telecom Company out there. Microsoft closely working with them, and the government data center is already ready. We are working with them out there for the last 1 year, and the consumer database data center is coming very shortly. It's under NDA. I can't disclose that one, but it's very shortly out there. Doha, it's been announced last week. So Doha data centers has been announced last week out there. And the Bahrain is also getting one out. Bahrain and Oman also in a talk out there. There's a company that called Orido, who's basically working in Oman as well. They're also working closely with Microsoft out there to developing their own data center. Again, government data centers are already ready. We are working within a couple of customers out there. One of the largest oil firm in the Oman in the region. They are my prime customers, and I'm a chief architect for them as well. So we have worked with them out there. So adoption, it's not going to be increased from now on. It's definitely going to, but adoption is increased. That's why they bring the data center. The
Hmm.
demand was out there because it's a $700 million freaking dollars out there. Nobody going to pour that one, especially in the war zones. You know the situation of our areas here. And Microsoft was very reluctant. So Amazon break the bias out there, break that cycle, and Amazon have added the first data center in Bahrain, and then Microsoft jumped in. So the adoption in Dubai and Middle East is crazy out there. It's literally a fascinating out there. But
Great.
the transformation is more on infrastructure as service. We are in a process that we are looking for re-architecting applications, refactoring applications, and also reimagining the analytical designs out there. Because here in this region, there's we call it slow train regions out there. So like if you talk about the European regions, if you talk about the American regions out there, these regions are very well adoptive and they are ahead of game out there. Means they have more demand than a supply, honestly speaking, out there. So, and it's driven by the out there. But in Middle East, they are trying to be one step behind the all these areas out there. So currently, mostly the analytical solutions that we have in past and Middle East out there, most of them they are descriptive ones. Historical information based reporting structures was available. Now they are embracing analytical for predictive analysis as well. They are also embracing now the modern architecture for the combining both that changing complete things. So the compute is the first place what they try to adopt. Second is in a cyber
Okay.
challenge. And a third segment which I have seen out there, the great adoption of a Power BI, great adoption of a data lake, great adoption of Microsoft ML and AI services. It was really surprising with the people using an ML. But where Microsoft is bidding, because you have to comply your career with Microsoft strategy if you want to work with Microsoft. Otherwise,
All
go
right.
for
Okay.
so
Thanks.
Synapse is
Thanks,
the one.
Usman. It's been a pleasure having you, and then the wealth of information and all those kind of things